Every day I wake up and I go to my computer and I think, oh man, what do I need to do today? And I've already forgot something. I forgot to exercise and I forgot to take my vitamins. I'm going to spend some time not exercising, but creating a device to remind me to exercise and take my vitamins. I'm taking an online engineering class by Mark Rober, and he challenged us to make something to reinforce a good habit in a week. This is my final project for that class. The requirements are: 1. I need individual switches for exercise and vitamins. If I've taken my vitamins, but I haven't exercised, then I can't push the exercise button, but I can push the vitamins button. Number 2, I need a physical spring up, push down button. Not a keyboard key, not a virtual button on a screen. Number 3, I want it to have a daily timer so that every morning it is automatically reset. I don't want to have to remember to exercise. Number 4, I want to use a microcontroller. I write software for work, so I'm challenging myself to learn microcontrollers. I have a little bit of experience with an Arduino microcontroller. Now I want to try to use a thing called an STM32. And number 5, I want it to have a nice build quality. So here's my device. It's the one up there. Whoa, you can't just show them. So I recently bought an Ender 3 Max. It's been described as a great to tinker with and upgrade printer, but maybe not the easiest to use. And it shipped in just a few days instead of a few weeks like the Prusa. One of the biggest things that I learned was how to level the bed. I thought that I knew how to level the bed. I ran CHEP's program and I couldn't knock off the lines, but when I would run a real print, it wouldn't stick to the print bed. So here are the 3 steps I learned to get good quality prints. Number 1, move the hot end as close as possible so that a paper doesn't move. Number 2, print the CHEP squares and make sure that you can't knock off the lines. Number 3, do a real print and you shouldn't be able to knock off the skirt lines. Obviously, the head should not be digging into the print bed, and you can hear it when it does that, so it'll be pretty obvious. Another thing I learned, don't print PETG on a stock Ender 3. Stick with PLA. The reason is there's a Bowden tube that goes into the hot end all the way down to the nozzle, and that tube will melt at 230 degrees. But when you're printing with PETG, you've got to go to temperatures like 250 degrees. And because I ran it at 250 degrees, the Bowden tube melted in my hot end, and it caused this big mess, and I ruined my printer. So I got a $60 Micro Swiss hot end, and now I can print PETG. But the new hot end doesn't come with a thermistor or a heater cartridge. So I went onto Amazon, and I found the Amazon Choice thermistor and heater cartridge set for an Ender 3. But when it arrived, it was 20 centimeters too short, and I had a DuPont connector instead of a JST connector. Choice! Well, I got to learn about those connectors. And it turns out that I actually like the DuPont connector better, but that doesn't change. The Ender motherboard is still a JST connector, so the part didn't work with my printer. I also learned that acrylic is hard to work with. I tried scoring the acrylic like about 20 times and it would break off cleanly. However, if I put the pressure point in the wrong spot or I was trying to break on an uneven line, I ruined my part. I learned that if you are careful with the heat gun, you can soften the acrylic or plastic so that it can follow this weird curve that's on the back of my monitor. And I also learned about the STM32F103. It's a popular and cheap board, but it's more complex than an Arduino, as you can tell by the name. The Arduino has a nice servo library, but in STM, you need to control the PWM directly by setting up a clock and dividing the clock counts, so it's a lot more complicated. I read that a servo needs a separate power source. USB has both 5 and 3.3 volts. I plugged my servos into the USB power, but they weren't working. So I thought, well, it's probably because it's not getting enough power. So I got a 9-volt power supply, and I plugged my servos into the 9-volt power supply. Then I plugged my STM and USB into 9-volt at the same time. And my STM32 blew up. I'm surprised that it didn't blow up my expensive MacBook. But that's the kind of thing that you learn learning electronic engineering. It's okay. I had a backup. I had a second STM32. This time, I won't plug it directly into USB and 9-volt at the same time. So I plugged my backup into the 9-volt. And I blew up the second one. And I learned my mistake that you can't put 9 volts into a 5-volt board. I submitted my final build in a non-working condition. However, I kept on working. While waiting for the chips, I learned a lot of things iterating on an enclosure. On the back of the monitor, there's 2 sets of VESA bolts. One is at 100 millimeters and one is at 75 millimeters. I was using the 100 millimeters for the mount, and I could use the 75 millimeters for my project. I designed the enclosure to be modular so that way I could iterate on different sections at a time. I learned that I need to have a 0.2 millimeter tolerance or gap between everything that I print. But I'm happy with the end result. Number 1, I have individual switches, one for exercise and one for vitamins. Number 2, the buttons come up with servos and I can push them down. Number 3, every 12 hours after I push down a button, then it comes right back up. Number 4, I learned STM32 microcontrollers. They're a lot more complex, but it's satisfying to learn it. And I have a lot more to learn, like how to make USB HID drivers. And number 5, having a nice build quality. I think it looks good to me, and I learned Fusion 360. I really love Blender, so when I first tried Fusion 360, I really hated it. After watching Mark Rober's videos and learning more about Fusion 360, then I started to get to like it. So the big question remains, has it changed my habits? For the last week, I've been taking my vitamins, and I exercised yesterday. The class is finished, I learned a lot, now I'm on my own, and I've got a good idea for the next project.